Hello, my dear students. Welcome to my YouTube channel that's Concepts of Chemistry. So, today's topic of the lecture is Gay-Lussac's Law of Gaseous Volume. First of all, we am talking about the scientist who have given this law. The scientist's name was Gay-Lussacs, and he has given this law in 1808. In last videos, I have forgotten to mention the name of the scientists who have given the different laws, so I'm writing it in today's video. So, the law of conservation of mass. Law of conservation of mass was given by Lavoisier. It is spelled as Lavoisier. It is given by Lavoisier in 1774. Law of definite proportions. This law was given by Proust, Proust, Proust in 1799. Law of reciprocal proportions was given by Richter in 1792. Okay, एक minute, hold on. The law of multiple proportions. First is multiple proportion in sequential manner. The law of multiple proportions was given by Dalton in 1808. By Dalton in 1808. Law of reciprocal proportions was given by Richter in 1792. Richter in 1792. So this was the names of the scientists who have given the different laws. So today's topic of lecture is Gay-Lussac's law of gaseous volumes. Let's talk about it. What does law of Gay-Lussac's what does the Gay-Lussac's law of gaseous volume states? This law states that Gay-Lussac's law states that gases react with each other. Gases reacts with each other in simple ratio in the simple ratio of their volumes of their volumes, and if the product is also gaseous, and if the product is also gaseous, the volume of the product, comma, the volume of the product also bears a simple ratio also bears a simple ratio with the volumes of the with the volumes of the gaseous reactants. Importantly, when all the volumes are measured under similar conditions of temperature and pressure. Similar conditions of temperature and pressure. So what does the Gay-Lussacs law says? It states that gases react with each other in the simple ratio of their volumes, and if the product is also gaseous, the volume of the product also bear a simple ratio with the volume of the gaseous reactants when all the volumes are measured under similar conditions of temperature and pressure. Let me take an example. I am taking the example of H2 gas plus Cl2 gas. These gases reacts to form HCl gas. Now you have to balance this equation. HR2 ClR2 in the reactants. In product I have to write 2HCl then to make it a balance equation. Now it is 1, and that's a 2. That means 1 volume of H2 reacts with 1 volume of Cl2 and forms 2 volume of hydrochloric acid. The simple ratio for this reaction comes out to be 1 is to 1 is to 2. Let me take another example. I am taking N2 gas plus H2 gas. It forms me NH3 gas. First of all, always you have to balance your equation. It's N2, I have to write 3H2 and then it becomes 2NH3 gas. I have first of all balanced the equation. Now 1 volume of N2 reacts with 3 volume of H2 to form 2 volume of NH3. Then the ratio will be 1 is to 3 is to 2. Okay, let me take one more example. I'm taking H2 gas plus O2 gas. It forms me H2O gas. Again, first of all, I have to balance my equation. That's 2H2. That's 2H2. Yes, now it's a balance equation. Now here 2 volume of H2 reacts with 1 volume of O2 to form me 2 volume of steam. So here ratio also comes out to be simple and the whole number, that is 2 is to 1 is to 2. That means here the ratio of all the gases in different reactions will be the whole number ratio. In first case of H2 Cl2 gonna form me HCl, the ratio was 1 is to 1 is to 2. In the second example, N2, it reacted with 3 volume of H2 to form 2 volume of NH3. The ratio was 1 is to 3 is to 2. In the third example, 2 volume of H2 reacts with 1 volume of O2 to form 2 volume of steam. The ratio comes out to be 2 is to 1 is to 2. So that was my Lussacs law of gaseous volumes. Now I have written one example, one numerical to understand it more in a better way. The numerical says how much volume of oxygen will be required for complete combustion of 40 ml of acetylene. So first of all, I have to write a reaction for this thing. Acetylene gas is C2H2. In the combustion reaction, we always add O2 gas, and it was also ethylene gas. So my dear students, please do always keep in mind whenever a hydrocarbon gets combusted, it always forms CO2 gas and the H2O liquid. Whenever any hydrocarbon, can it be alkane, alkene, alkynes, it is combusted completely in the presence of oxygen, the products are always carbon dioxide and water. So now my dears, we have to balance this equation. We are having two carbons, two carbons over here. H2, 2 are there. Oxygen, 4 and the 5. In that case, I'm taking this to be so sorry, it comes out to be 2. Now it's in 4 carbons. Now here's the 4 carbons. Okay, now it's 4 hydrogens, so it's a 4 hydrogen product also. Now it's 4 to 8, 9, 10, 10 oxygen in the products. I have to write 5 over here. So that's my whole number ratio. So my whole number ratio comes out to be 2 volume of acetylene reacts with 5 volume of O2 to form 4 volume of CO2. The H2 was liquid, so I'm not taking that thing because Gay-Lussac's law was for only gases. Now what next question is saying? How much volume of carbon dioxide will be formed? And the first part was how much volume of oxygen will be required for the complete combustion of 40 ml of acetylene. So the ratio between acetylene and oxygen gas, first of all, this was 2 is to 5. Now how much oxygen will be required to react with 40 ml of acetylene? The ratio, we am solving this ratio to 1, that's 2 is to 5. Hold on. Now the ratio was 2 is to 5, then it will be 1 ratio 5 is to 2. Then 40 ml of acetylene will react with 5 by 2 into 40, and this thing comes out to be 100 ml. So I have calculated the volume of oxygen that will react with 40 ml of acetylene, and I have used the ratio 2 is to 5 according to the balanced chemical equation for solving this question. So the 2 is to 5 is the ratio. 2 parts, or the 2 volume of acetylene. 2 volume of acetylene reacts with 5 volume of O2. Then 1 volume of acetylene will react with 5 by 2 volume of O2. Then 40 ml will react with 5 by 2 into 40, that comes out to be 100 ml of O2. So my first part is solved of the from the question, I have calculated the volume of oxygen that will react with 40 ml of acetylene. Now what next? The next part is how much volume of carbon dioxide will be formed. Now I have to evaluate the volume of carbon dioxide. So I'm coming back to my reaction. I'm again taking the ratio of acetylene and the ratio of carbon dioxide. Now I'm taking C2H2 gas ratio the CO2 gas. The ratio comes out to be 2:4. Next it comes out to be 1:2. Then 40 ml of acetylene will produce 2 into 40. It comes out to be 80 ml of carbon dioxide. So hopefully my students, you got the second part also. So here what I have done in the first part, I have used the ratio of acetylene with oxygen. In the second part, I have used the ratio of acetylene with carbon dioxide. The first was the 2:5, the ratio of acetylene and the O2, and the second was the ratio of acetylene with the CO2, that comes out to be 2:4, that comes out to be 1:2. From there I got 80 ml of CO2. So my dear students, hopefully you got this question. So the today's video was not of that great length, but hopefully you got this law. That's the Lussacs Law of Gaseous volume. So I hope you all understood today's lecture. I have given my phone number on the thumbnail of this lecture. So if any one of you wants to book a paid one-to-one online class to clear doubts, contact me on my phone number. Please like, subscribe and share my channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.